So in this video, we're going to write the equation of a parabola given the focus and directrix, but this time we're going to have a parabola that moves around to a location other than 0, 0. And then we're also going to determine the focus and directrix of a parabola that is also centered at HK, so it moves around, when given the equation. So you'll notice here that this slide is very similar to what you saw in the previous video, but everything is now centered at the vertex point h comma k. So you know that vertex form uses h comma k. Remember, we have the negative h in here because when we put it into the equation, it's the opposite of h, and the k is added onto the outside. And then you'll notice here that the focus, instead of being centered at 0, 0, it's now at h comma k. So we're going to have to add p or subtract p to the focus or the directrix. So just being very, very careful. We're still utilizing that p value here in exactly the same way, but now we're just moving the vertex around just a little bit. So now we're going to write the equation of a parabola with a vertex at h comma k, so it gets moved around a bit, with the given focus and directrix. So looking down at example 1, let's draw a sketch of this out. So we have the focus at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So at 4, 8, we have our focus. And then our directrix is occurring at y equals -2. So down here is our horizontal line for our directrix of y equals -2. Now we know that our vertex needs to lie in the middle of these. So we look at our y values here and we know it's going to be in the middle. So you can either count down and up to figure out where the middle is, or you can just take the y values and average them. So we have 8 and we have -2. So if we average those out, we get 6 over 2, which is 3. So we know that our vertex is occurring at x is 4, y is 3. And then if we count that out, we can see, well, the distance here is 5 units, the distance here is 5 units. So sure enough, that is our middle vertex point. So now we're going to move forward and we're going to write our equation. And the equation that we refer back to is y equals 1 over 4p times, in parentheses, x minus h, because it's the opposite of h, squared plus k. So if we can find those key values of p, h, and k, we can write our equation. Now, first, before we even start plugging in our p value, we need to notice that this is going to open up because we want it to go around the focus. So we know we're going to have a positive p value. So here we can see that our p value is 5. So we'll do y equals 1 over 4 times p, which is 5. So that becomes 20. And then my h and k values just come from my vertex. So my h value is 4 and my k value is 3. And as a result of this, we have x and then the opposite of h, so -4 squared plus our k value, which is 3. So there's our equation for example 1. Then looking down at example 2, again, we're going to draw another sketch here. So here we have a focus at x is -1, y is 1, 2, 3. So there's our focus point at -1, 3. We then have a directrix all the way up at 7, so 1, 2, 3, 4, so that's 7. So there's our directrix at y equals 7. Then we know that our vertex point needs to go in the middle of these. So again, you can either just count up and notice that it does hit here at x is -1, y is 5, or you can take those two values, 7 plus 3, and average them, so that becomes 10 over 2, which is 5. So from here we can see that our vertex occurs at -1, 5. We can also see that our graph is going to open downwards around that focus point. So again, we're going to refer back to that equation of y equals 1 over 4p and then x minus h squared plus k. So we can see that our p value is, if we look carefully, it's 2. So the vertex is 2 units away from both the focus and the directrix, and it's going to be a -2 because the graph is opening downwards. So here we have y equals 1 over, well, 4 times -2 is -8. And then our h and k values come from our vertex, so h and k. So it's x minus h, or the opposite of h, that becomes x plus 1 squared. and then plus 5 because k is a positive 5. So in these two examples, we're going to identify the focus and the directrix for the given parabola. So here we can see in our examples that we are no longer centered at 0, 0. So the first thing that we need to do is we need to identify our vertex, which is going to be at the opposite of h, comma, k. So here we have opposite of negative 3 is 3, comma, k is 2. So if I draw a picture over here of what's going on, we have a vertex at 1, 2, 3, 1, 2. So this is our vertex here at 3, comma, 2. I then need to determine my p-value in order to find my focus and my directrix. So here, remember, my p-value is going to be found by using this coefficient out in front here. So we have 1 over 4p is equal to 4. And remember, the trick here in order to solve for the p-value is to put 4 over 1 and cross multiply. So we have 1 times 1, which is 1, equals 4 times 4p, which is 16p. So to get the p alone, we divide by 16. So our p-value is 1/16. So it's a very small p-value. So here, since it's positive, we know that this parabola is opening up. So what we can do here is in order to find our focus and our directrix, we're just going to take our vertex and we're going to add or subtract 1/16 to it. So here we're going to add 1/16 to 2. And if we do that, we get a focus point right here of x is still 3, but y is 2.0625, and you can leave it in fraction form too if you want. It would just be 2 and 1/16. And then we also can draw our directrix by subtracting 1/16 from 2. So that would be down here, and it'd be a horizontal line at y is equal to 1.9375, or you can list that as 1 and 1/15, whatever you would like to do. But all we do is take our vertex point and add or subtract that p-value to it. So last example here, we can see that our vertex point, again, is, remember, the opposite of h, comma, k. So we have, that's going to be -1, comma, -4. So if we draw a little sketch over here, we're at -1, -1, 2, 3, 4. So here's our vertex point down here. So we can label that accordingly. I can then also see that my graph is going to open downwards because of that negative out in front. So I can even draw a little sketch here of my parabola. So now from here, I need to determine my p-value. And remember, my p-value uses this value here out in front. So we're going to create a little equation of 1 over 4p is equal to -5 over 3. And then we cross multiply, so you end up with 1 times 3, which is 3, equals, you get -20p. So you divide by -20, and you get a p-value that's equal to -3/20. So now we can simply take this value here and apply it to our -4 by adding and subtracting it in order to find our focus and directrix. So if we take -4 and we add -3/20 to it, we are going to get -4.15, which is what we expect. We expect our focus point to move downwards a little bit, so it's inside the U. So this is at the point -1, comma, -4.15. And then if we take -4 and we subtract a -3/20 from it, that's really like adding 3/20 to it, and we end up with a -3.85. So our directrix is going to be up just a bit up here. It's going to be a horizontal line at y equals -3.85.